Hey guys, this video is for you if you are a 4th sem VTU student writing M4 internal exam or VTU Semester exams. And this video is from the video series that we are doing on 18 scheme M4 subject. And this includes the solutions to the most asked or the most repeated questions in the VTU Semester exam. And please subscribe to our channel for more videos and share this video with your other friends. Also watch this video till the end to know about our M4 video scanner. So the question is, find the bilinear transformation which maps the point z equal to 1i minus 1 to the points w equal to y minus 2. So what is given here? So if you have a input-output table here, if z is the input, z is the input and w is the output, right? So if z is 1, if input is 1, output is 2. Okay. If input is I, the output is I. If the input is minus 1, the output is minus 2. This is what is given to us. Okay. We need to find w, which is nothing but a complex function f of z, such a complex function that transforms 1 to 2, I to I, and minus 1 to minus 2. Okay. So where do we start from? The w, or this complex function is not any complex function. It is the one that bilinearly transforms the function. So we have some information in terms of bilinear transformation. So a complex function of the form w is equal to az plus b over cz plus d bilinearly transforms 1i minus 1 to 2i minus 2. So we should find a, b, c, d given this information, using this information, and substitute back, and that will be my complex function. Okay. So how do you find ABCD? The first step is, let us substitute z and w in this equation. Okay. So in the first case, if z is 1, w is 2, right? So w is 2 equal to z is 1, a times 1 plus b over c times 1 plus d. Okay. That is nothing but 2 times c plus d is equal to a plus b. Okay. Or a plus b as it is minus 2c minus 2d. If these 2 comes this side of the equal to sign, it will be negative. So my first equation is a plus b minus 2c minus 2d is equal to 0. So we will use, for each of these information from 1 to 2, I to I, minus 1 to minus 2, we will get one equation. Okay, so how many pairs of numbers we have here? 3. So we will get 3 equations for 4 unknowns a, b, c, d. Okay. So let us find the second equation. Second equation is, if z is I, w is I. So w is I if z is I over ci plus d. That is nothing but I times ci plus d is equal to ai plus b. Okay. So I times ci is ci square, I times d is di is equal to ai plus b. Okay. Or ai plus b as it is. I square is nothing but minus 1, right? So minus c will come to this side, to the right of the equal to sign. We will get plus c plus di will become minus di is equal to 0. Okay, so my second equation is ai plus b plus c minus di is equal to 0. From the second pair of numbers, I got second equation. So finally, the third pair of numbers, minus 1 and minus 2. So if z is minus 1, w is minus 2. So w is minus 2 if z is minus 1. Okay, c times minus 1 plus d. That is nothing but minus 2 minus c plus d minus a plus b. Okay, so minus a, if it comes this side, we will get plus a, plus b will become minus b, minus into minus plus 2c as it is, minus into minus into plus minus 2d is equal to 0. So my third and final equation is a minus b plus 2c minus 2d is equal to 0. So we need to find 4 unknowns a, b, c, d, but we have only 3 equations from the 3 pairs of numbers given to us. So let us go to the next step. Okay, the next step is eliminating a from this 4 unknowns. Okay, Okay, so the next step is eliminating one of the unknowns from these three equations and get two more equations with just the three unknowns. Okay, how do we do that? So first, let us subtract 3 from 1. So 1 minus 3 gives us, 1 minus 3 will give us, 1 is a plus b minus 2c minus 2d is equal to 0, minus b, equation 3 is a minus b plus 2c minus 2d equal to 0. When you subtract, what we should do? We should change all the signs. Right? Not here. Okay. So a minus a is 0. Okay. B plus b is 2b, minus 2c is minus 4c, minus 2d plus 2d is 0 is equal to 0 minus 0 is 0. So we eliminated a term and we got the equations in terms of b, c, d. I know the quotient of d is also 0, but I will take it as 0d rather than just 0. Okay. So it is 2b minus 4c plus 0d is equal to 0. Okay, we have eliminated a using 1 and 3. Now let us use 2 and 3 to eliminate a. How do you do that? If you subtract right now from 2 minus 3, ai minus a is not 0. Okay, you should have I on both the term, then only they will get cancelled. Okay. Now how do you do that? So I can, after this, 1 minus I times 3 if I do. Okay. So if I multiply I to this equation, then I will get ai here. So ai minus ai is 0. So 2 minus equation 2 minus I times the equation 3. Okay. So equation 2 is nothing but ai plus b plus c minus di is equal to 0. I times equation 3 is ai minus bi plus 2ci minus 2 di is equal to 0. Now we need to subtract this, right? So how do you subtract? To subtract, you have to change all the signs, right? So what will you get? ai minus ai is 0. b plus bi. See here, b plus bi is not 2bi or something like that. You have to have I on both the terms, then only you can add or subtract. Otherwise, you just have to factor out b. Okay, if you factor out b here, you will get 1. Factor out b here, you will get plus I. So b plus bi is nothing but b times 1 plus I. So it is nothing but b times 1 plus I. Similarly, c minus 2ci. c minus 2ci. Again, there is I only on the one term. Okay. So we have to factor out c. If you factor out c here, you will get 1. If you factor out c here, you will get minus 2i. So it is nothing but plus c 1 minus 2i. But here, minus di plus 2 di. Both the terms have I. So it is just 2 minus 1 is 1 di, or just di is equal to 0. Okay. Again, here we have eliminated a term. We got only equation only in terms of b, c and d. Okay. So it is nothing but 1 plus I times b plus 1 minus 2i times c plus I times d is equal to 0. That's all. That's not here. So from these three, we use these three to eliminate a and get equations, two equations with three unknowns. We know how to solve three unknown two equations. This is a method I'll tell you. From that method, we will find BCD, substitute back BCD here, find A, and substitute ABCD in this. Okay. Now let's find BCD using these two equations. So if we have three unknowns, BCD, and two equations, how do you find BCD? So first write down all the unknowns here. Okay, BCD, and add a minus sign to the middle unknown. In the denominator of B, take the determinant of coefficients of C and D. Okay, so what are the coefficients of C and D? In the first equation, coefficient of C is minus 4, coefficient of D is 0. The second equation, coefficient of C is a complex number 1 minus 2i, coefficient of D is just I, is equal to, in the denominator of minus C, take the coefficients of B and D. Coefficient of B is 2, coefficient of D is 0, coefficient of B is 1 plus I, a complex number, coefficient of D is just I, is equal to, in the denominator of D, take the determinant of coefficients of B and C. Quotient of B is 2, quotient of C is -4, quotient of B is a complex number 1 plus I, quotient of C is a complex number 1 minus 2I. Okay. So now we have to solve this to find values of B, C, D. Okay, how do we do that? So B over, how do you open a determinant? This into this minus this into this. Principal diagonal element minus other diagonal elements. Product of, so minus 4 times I is minus 4I minus 0 times 1 minus 2I is 0. Okay. Is equal to minus C in the numerator as it is, denominator. 2 times I is 2I minus 0 times 1 plus I is 0. Okay. Is equal to D as it is, divided by 2 times 1 minus 2I, that is nothing but 2 times 1 is 2 minus 2 times 2I is 4I, right? Minus 4 times 1 plus I. Minus 4 times 1 is minus 4, minus 4 times I is minus 4I. Okay, so this is the denominator of D. So what will this be? It will be 2 minus 4I, minus into minus plus 4I, minus into minus plus 4, okay, minus into minus plus 4I. Okay, so minus 4I plus 4I get cancelled, it is nothing but 2 plus 4 is equal to 6. So what do we have here? B by minus 4I is equal to C by minus 2I. I have sent this minus sign from numerator to denominator, is equal to D by 6. Okay. After this, the next step is nothing but B is equal to minus 4I, okay, equating the numerator and denominator. So C is equal to nothing but minus 2I and D is nothing but 6. As simple as that. Okay. So from two equations, 3 unknown, we use determinant method to find the 3 unknowns. Now we will substitute this B, C, D value in the first equation and find A. Okay, let's do that. How do we get that? So A plus B is nothing but minus 4I minus 2 times C is nothing but minus 2I minus 2 times D is nothing but 6 is equal to 0, right? That is nothing but A plus into minus 4I minus into minus plus 2 times 2 is 4I minus 12 is equal to 0. Plus 4I minus 4I get cancels. A minus 12 is equal to 0, nothing but A is equal to 12. Right, now we found out A, B, C, D. Let us substitute this back A, B, C, D in W, okay, and find the complex function. Okay, so the A, B, C, D values are here. Let us substitute them here. W is equal to A is 12 times Z plus B is minus 4I divided by C is minus 2I times Z plus D is 6. Okay, so if you multiply, what will you get? 12Z plus into minus 4I over minus 2IZ plus 6. Okay, so this is the W. This is the complex function, okay, that transforms 1 to 2, I to I, minus 1 to minus 2. Okay, you can simplify one more step here. If you take 2 common from the numerator and denominator, what will you get? 6Z minus 2I over minus IZ plus 3. So 2 get cancels. W is nothing but 6Z minus 2I over minus IZ plus 3. Okay. So most of the time he'll ask only for you to ask only to find the complex function by linear transformation. The W is equal to this AZ plus B minus CZ plus D by DCZ plus D. Sometimes he'll ask you what are the invariant points. Okay. So what are the invariant points? Okay. The invariant points under this transformation are the points which remain same, okay, in both input and output, both in Z and I or W. So one such point is here. So if you substitute I in this equation, you will get I as the output. Okay. So what are the other invariant, such invariant points? We should find that. So one point is here already. Okay. So how do you find invariant points? Okay. Next step is to find invariant points. Okay. The non-varying points. Substitute W equal to Z. Okay. In this. So if you substitute w is equal to z, what will you get? Z is equal to 6z minus 2y over minus iz plus 3. So we have to solve this and find the values of z, and those values of z is nothing but invariant points. You can also substitute z is equal to w. You can substitute w here and find w value. Doesn't matter, you will get same answer. Okay. So let us find the invariant points. But this is the required bilinear transform or required complex function that transforms these 3 points to this 3 point. Okay. Okay. So we have substituted z, w equal to z. So let's send this side. We will get z times minus iz plus 3 is equal to 6z minus 2y. Okay. It is nothing but z times minus iz is minus I z square plus z times 3 is 3z is equal to 6z minus 2y. Okay. Which is nothing but minus I z square plus 3z. If 6z comes inside, it is minus 6z. If minus 2z comes inside, it is plus 2y is equal to 0. Okay, what will you get? Minus I z square plus 3z minus 6z is minus 3z plus 2y is equal to 0. So this is a quadratic equation. A z square plus bz plus c. Okay. So if we have ax square plus bx plus c, we will use the quadratic equation formula, right? So how do you find z? Z is nothing but minus b. Minus b is nothing but minus 3. Minus b plus or minus under root b square. B square is minus 3 square minus 4 times a is I. C is 2i. Okay. Divided by 2a. A is minus I. Okay. Minus b plus or minus under root b square minus 4ac by 2a. Okay. So what will you get? 3 plus or minus under root minus 3 square is 9. Minus into minus plus 4 into 2, 8. I into I square over 2 times minus I is minus 2i. Okay. We know I square is nothing but minus 1. So it is nothing but 3 plus or minus 9 minus 8. 9 minus 8 is nothing but 1. Right. So 1 by minus 2i. Okay. So you can send this I. Okay. Let's first solve this. Okay. You will get square root of 1 is nothing but 1. So it will get 3 plus or minus 1 over minus 2i. Okay. Z. So that is nothing but z is equal to 3 plus 1 over minus 2i or 3 minus 1 over minus 2i. You have to split this. One condition for plus, one value of z for minus. Okay. So 3 plus 1 is 4 by minus 2i. Okay. So 2 ones are 2 twos are minus 2 by I. Okay. Minus 2 by I or minus 2 into minus I. That's nothing but 2i. We have to know 1 by I is nothing but minus I. Okay, so this is the identity of complex number. So in the I in the denominator will come to numerator with minus symbol. So minus 2, and this is one of the invariant point is 2i. Okay, so another one is 3 minus 1 is 2 over minus 2i. 2 ones are 2 ones, I get cancelled, so it is nothing but minus 1 over I, which is nothing but minus 1 minus I, which is nothing but I. So another invariant point is I. This one we already knew. So I and 2i are the two invariant points. There will always be only two invariant points because this function, you will get quadratic function. So the roots of quadratic function, the values of z are two values. These are the two invariant points of this bilinear transformation. This is a bilinear. So if you substitute I or 2y in place of z here, you will get I or 2y. Okay. Let's see another problem. The surest way to improve your CGPA is to study the previous year question papers, and this works for all branches, any subjects in VTU. For M4 subject, we have this amazing new product that you simply must have, and this is VTU Exam Video Scanner for M4. So this book includes all the previous question papers, model papers on M4, and it also includes solutions to all the questions in the question papers and model papers. Each solution will have a QR code which will open a video where that solution is explained step by step. Okay. Find the link to buy this book in the description and get your own M4 video scanner today.